Okay, so we're going to be talking about proving triangles congruent today. All right. First off, this is how you're going to fold your notes. Yeah. You can cut the flaps if you want to. But the first one we're going to end up talking about is side, side, side. What it means, and it tells you in the name, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So that's going to look like, whoop, it'll look something like this. They won't always be where it matches completely, but here. Okay, there we go. So as long as you have three sides that are congruent, then it's a side, side, side. All right, then side, angle side, is that if two sides and the included angle of one triangle are congruent, so side, side, included angle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. All right, the next one, it's a little bit of a breaker. This is our hypotenuse leg theorem. Pretty much you need a right angle. So the hypotenuse and leg of a right triangle, and you'll remember that the hypotenuse of a right triangle is this one right here. It's the one across from your 90-degree angle. If it is congruent to the hypotenuse and leg of a second right triangle, then the triangles are congruent. So pretty much it's going to end up looking something like this, where your hypotenuse and your leg are congruent. Now, you could also have it say that the other leg was congruent. That would also work. It doesn't matter which leg is congruent as long as they're the corresponding leg on both triangles. Okay, and make sure you highlight the word congruent, or at least put a box around it. All right, now angle side angle is kind of like side angle side, but the reverse. Now you need two angles and the included side of one triangle. So two angles, angle, angle, included side. Okay, and if they're congruent to two angles and the included side of a second triangle, then the triangles are congruent. Now that side that is congruent has to be in between the two angles. It's sandwiched in between the two congruent angles. And that's what that word included means. All right, now angle, angle, side. All right, I'm going to draw my triangles first, just so I'm ready. If two angles and a non-included side of one triangle. So this could look like side, angle, angle. Side, angle, angle. It could also be on the other side where it's angle, angle, side. As long as you have those three components, then it'll be congruent for both triangles. And then this blank isn't supposed to be there. I got a little too excited and I gave you the answer already. So you're just going to have to end up highlighting the word there. And again, then these triangles are congruent. And now these are just, this is just kind of getting you into it. I don't expect you to know all of these right now. I just want you to be familiar with it. I had to make it. And this is from a game that's very familiar. I love that. I definitely did not time that. And I can't say, you know, the other I word because copyright, but intruder alert. Now here's the deal. Angle, angle, angle does not work to prove triangles are congruent. If you have angles that are congruent, that doesn't work. And it's also kind of like, it literally makes that noise when you say the three letters together. The other one is side, side, angle. And I don't want you to make it angle, side, side. And if you just look at those letters backwards, you can see why we don't say angle, side, side. Because then we feel like that. Now, these do not work to prove that triangles are congruent. So make sure that you highlight this. This does not work. If you could put lights on it, I would want you to put lights on this. All right, so let's go through some examples, and we're going to see if we can prove that the triangles are congruent, just with what they've given us. So we're looking at triangle A, B, C, with E, D, C. And I'm numbering these just so you guys know which ones are corresponding. You don't have to do that, but it helps me when I'm writing it down. So notice angle A and E, they're congruent angles. So I have a congruent angle. I have another congruent angle. And then I have a congruent side. Which means it's going to be angle, angle, side. For the next one, they've only given us that these angles right here are congruent. But by using the reflexive property, you can say, because this is a shared side, that this line right here is also congruent, so that they're congruent to each side. Which means I've got an angle, side, angle. And notice I went from right to left this time. It doesn't matter. As long as you have it in some circular order, then it works. All right, for number 3, I want you to notice that right here, this angle ABF is also going to be a right angle because its supplement right there is a 90 degrees. So we know that's going to be a right angle. All right. Let's see. And so then we've got side, angle, side. So, not this. All right. Now, if the hypotenuse had congruency marks on here, then we could have used that hypotenuse leg. But for this situation, we can't. All right, so this next one looks really complicated, but let's just draw it out. So we've got A, B, C, D, E, F, A, B, and, oops. A, B, and EF have 2 lines. ED and BC have a line each. And then angles D and angle C are congruent. So then I've got a side, side, angle. And that means it cannot be proven because literally the letters spelled backwards are a sh word. And that's how we feel when we can't do that. So that's why this cannot be proven. SSA is not a valid reason. Same thing as AAA. Because it makes you go, ah. All right. So looking at angle 5, you're like, oh my gosh, it's a lot of lines. But notice that these are just being bisected, right? So what's happening is, and you can kind of split them out, is we've got angles A, C, E, and B, D, F. Angles C and F are right angles. Line AC is congruent with line FD. And line AE is congruent with line BD. In this case, it would be hypotenuse leg because your hypotenuse is congruent. One leg is congruent of the right triangle. If you didn't have that right triangle to begin with, then you would not be able to use HL. All right, this last one, I'm going to split it out again. So we've got triangle A, B, D, and C, E, F. Angles D and angle C are congruent. And this part that is overlapping, we know it's going to be congruent because it's the same part. That means BD is going to be congruent with CE. Now, you also notice that this one right here is 1 and 3, 1 and 3, but those two parts are congruent to each other and they're corresponding. That means that entire leg right here is also congruent. So I'm going to put a line on this one. Now, some people might want to do hypotenuse leg on this. We can't because there's not a 90-degree angle. But we do have a side, angle, side. And that's all I got.